Hello, a very good morning to all of you. Today we are going to discuss cycloaddition reaction. Yesterday we are discussing classification of pericyclic reaction and first reaction we take that cycloaddition reaction. Second is electrocyclic reaction and third we see that uh, sigmatropic rearrangement. Okay, so cycloaddition reaction, there are so many different kind of cycloaddition, just like 4 plus 2 addition, 2 plus 2 addition. There are 1,3 dipolar reaction also including in cycloaddition reaction. Okay, so what happened in cycloaddition reaction? There are so many different types, so we are going to discuss today cycloaddition reaction and different type of cycloaddition reactions. Okay, so we will see that cycloaddition reaction. First, there is an announcement: exclusive English recorded course. You got English recorded course, CSIR net June 2024 aspirants. Those who are preparing for June, please listen to carefully, because they got a recorded English course, CSR net course for June 2024. Okay, and subjects are life science, chemical science, physical science, and mathematics science. All subjects they are included, and they give 70% discount. The 70% hours promo code is IFAS 70. To avoid this offer, directly go that site ifasonline.com. Website is here given to you. You enroll now and register now, and if you have any query you can call in that number 91722 917226688. You can call on that number and directly ask any query if you are related to course of recorded or any other batch related or any other study material also. So you can directly ask on that number. You call directly and ask him. They will solve your problems. Now we will see today cycloaddition reaction. So hello guys, hello. So today we will see that cycloaddition reaction, how many different type of cycloaddition reactions are there. So there are so many different type of cycloaddition reaction. Which are they? Sir, first there are 4 plus 2 cycloaddition. Okay. Second one is 2 plus 2 cycloaddition. Third one is 6 plus 4 cycloaddition, and there 4 plus 4 cycloaddition, sir. So there are so many different types, and you want to know that different types of cycloaddition reactions are there. And in 4 plus 2, in first of all we take 4 plus 2. In 4 plus 2 there are so many different type of classification in the 4 plus 2 cycloaddition. So which are they? First is very important, related to the CSIR net exam or any set or gate exam. Frequently asked from that topic, which is Diels-Alder reaction. Okay, Diels-Alder reaction means, what does it mean? We will see further. Okay, then next one is, very well, the CSR net favorite topic is 1,3 dipolar cyclo addition. now CSIR net exam will ask you on that intermediate of 1,3 dipolar cyclo addition. So you need to understand the basics of 1,3 dipolar cyclo addition. Okay, and after that you have that next classification is allylic cation cations or anions, allylic anions or cations. Okay, and last one, fourth one classification is there is chelation. So chelation, what does it mean? It is a very important reaction or chelation in the process of 4 plus 2 cycloaddition. Just like we will see in next page, what is Diels-Alder reaction, what is 1,3 dipolar cycloaddition, and what is allylic cation and anion reaction and chelation. In that whole we see that in next page 4. First there is Diels-Alder reaction. Diels-Alder reaction. So what does it mean? First, Diels-Alder reaction is that Diels-Alder reaction is there is a diene plus dienophine. That is, how many total electrons are there? 1, 2, 3, 4. 4 pi electrons are there. Okay, and 2 pi electrons are there. 2 pi electrons are there. So 4 plus 2 cycloaddition is happen here. Okay, and in the heating, presence of heating, that is cycloaddition reaction. They goes here and pi bond will attack here. So how many pi bonds are there? 3 pi bonds are there. 3 pi bonds. Okay, and in the formation of 6-member ring, the product we got 6-member ring. And how we give number 1, 2, 3, 4, 5, 6. Okay, so you will get 1 pi bond and 2 new sigma bond and plus 2 new sigma bonds are there. 2 new sigma bonds are there. Okay, so there Diels-Alder reaction you need to understand very carefully, because so many questions arises from Diels-Alder reaction topic. It's a very big topic, actually huge topic, and it's very interesting, and so many examples are there but first of all I want to explain that basics of that Diels-Alder reaction. That's it. Okay, so after that 1,3 dipolar reaction, what happened in 1,3 dipolar reaction we want to see. Then there is one announcement is there. CSIR net exclusive live batch, life science original batch, chemical science alpha batch, physical science gravity batch, mathematical science Lakshya batch. Okay, by starting from 8 Jan you can enroll now for June CSIR net exam. On that side is there ifasonline.com. Okay, you go directly search on Google or Chrome ifasonline.com and you got a first link and enroll there directly. And if you have any query you can ask here. Here is a number 91722668888, and they give you flat 70% off, and you use coupon IFAS 70. Okay, so enroll now and success your journey fast. Thank you so much. So there, BARC exam is also there nearby, so you can enroll recorded course you got and get a whooping. ठीक है, तो आपको 50% flat 50% discount you got, and you want to use coupon code IFAS50. Okay, you want to use IFAS50 code, then you got 50% discount, and enroll now with the IFS and best strategy and success your journey. Okay, जल्दी से जल्दी एनरोल कीजिए IFS में, क्योंकि नेट गेट सेट या कोई भी MPSC की एग्जाम या कोई भी एग्जाम जो भी हो रही है गवर्नमेंट रिलेटेड या महाजन की या फसाई की कोई भी एग्जाम हो रही है, वो आप यहाँ पर एनरोल कर अपनी एग्जाम का प्रिपरेशन कर सकते हैं, क्योंकि हम बेसिक से आपको बताएंगे. तो एनरोल नाउ, enroll fast, because we will see that all the exams we want to crack it. So for cracking all the exams we need to study very basics from the organic chemistry, inorganic, or all subjects of IFS, chemical science, life science, mathematical science, physical science. Okay, you need to study very theoretically. Which subject you have is you go through with the basics. Okay, so next, Diels-Cellular reaction you need to understand. Then after that you want to see that 1,3 dipolar reaction is there. What, sir? 1,3 dipolar 1,3 dipolar cyclo addition reaction. Cyclo addition 1,3 cyclo 1,3 dipolar cyclo addition reaction is there, or we call as. So in the 1,3 dipolar cyclo addition reaction there is a starting material. Which starting material they are used? They have nitrogen containing double bond, and here CH2 negative charge, and here on nitrogen there is a positive charge. Okay, this is the starting material, and plus with the dienophile. This is dine and this is the dienophile. How we catch it? This is the dine or dienophile. This 2 pi electrons and this 2 pi electrons. How many total electrons are there? 4 pi electrons are there. Okay, and how many electrons in that pi bond? There are 2 pi electrons. So 4 plus 2 cyclo addition is happened, and in the presence of doing what happened, they are negative charge will attack here. Okay, this pi bond will become neutral here. Okay, so what we get next? There positive charge on CH2 atom. Nitrogen is neutral now, and here CH2 with negative charge, and here is dienophile, and now we will attack here. We will attack negative charge is like a nucleophile. They will attack, and this pi bond will attack here and form new sigma bond. This negative charge attack on that dienophile and form new sigma bond, and this pi bond form new sigma bond. What does it mean? And how many ring you got? How many member ring you got in that reaction? Okay, so you need to remember that this is the carbon number 1, this is the nitrogen number 2, this is the carbon number 3, this is the 4 number, and this is 5. But it means you got 5 member ring. You got 5 member ring, sir. So you got 5 member ring. with a nitrogen containing 5-member ring. What does it call? It's like pyrrole, but its derivative like spirol, like piperidine. How it's called? Piperidine. Piperidine means there is no pi bond, so it's piperidine. Okay. So there is no two new sigma bond is there. Which are they? This is new sigma bond. This is new sigma bond. So you need to know there are two new sigma bonds are there in the product, and how many how many containing ring member? There are 5 member, 5 member, 5-member ring is formed. 5-member ring is formed. Okay. So good morning, Tisha. A very good morning to you, Tisha ji. Very good morning to you. And we need to understand that 1,3 dipolar reaction. In 1,3 dipolar reaction, it's very important to you. Okay. So what you want to do next? There are 1,3 dipolar reaction. The starting material is like this: nitrogen containing CH2 and CH2. One is CH2 is negatively charged and one CH2 with the pi bond. And this pi bond will shift here, and this positive containing nitrogen is become neutral. After that, that positive charge on that carbon atom, that that carbon atom containing positive charge here, and this dienophile is here. They containing 2 pi electrons, and that system only, that whole system is containing 4 pi electrons. That 2 electrons from negative charge and that 2 electrons from that pi bond. Okay, so there is 2. After that, what happened? After that, reaction is happening. So what happened? What we get? So after that, we get that negative charge will attack here on that 4 number of carbon atom. After that, that pi bond is attacked where, sir? In positive charge of carbon atom. That is the main important thing you need to understand in whole organic chemistry, which is a nucleophile and which is a electrophile, because so many people are doing wrongly things. They are attacking from positive charge to directly here and pi bond, and they are doing that pi bond will attack on negative charge. Does not happen like that, because negative will negative is not attack. Negative and negative charge will not form attack. So that negative become attack here on that 4 number of carbon atom, and that pi bond will attack here on that carbon atom of number 1. Okay, you need to understand the basics of organic and which is a nucleophile and which is a electrophile. If you are clear your concept of nucleophile and electrophile, then your arrow become very correct. If you understand which is a nucleophile and which is act as a nucleophile, which act as an electrophile, then you will become a very good master in organic chemistry. Okay, so after that we got 5-member ring. How many member ring are there? 5-member ring. Okay, so what happened in 5-member ring? You give the number of that ring: 1, 2, 3, 4 and 5. Okay, you got 5-member ring is there. After that, what happened? After that, what happened, sir? You got 5-member ring, 2 new sigma bond is there, and 5-member ring is formed in 1,3 dipolar cycloaddition reaction. Okay, you got it? Okay, after that, I want to say that cis and that FMO approach, frontier molecular approach. molecular orbital approach. FMO approach means, what does it mean? Sir, frontier molecular orbital approach is there. So which reaction is there? So there are S-cis alkene. S-cis alkene or diene we call as is more reactive or not? S-cis alkene is more reactive or not? Please say it in comment section. S-cis alkene is more reactive or trans S more reactive than S trans alkene or diene. We said at because in trans diene, this is the diene, trans diene. So this trans diene is reactive or not, and this is a cis diene. So which is more reactive for Diels-Alder reaction, transdiene or cisdiene? Which is more reactive? Please comment in the comment box which is more reactive in this form of cisdiene or transdienes. Which is more reactive? This is transdiene, S trans, S trans. Okay, and that is S cis. Okay, this is cis S cis cisdiene. विक्रम, वेरी गुड विक्रम, बहुत बढ़िया, आपकी तैयारी बहुत अच्छे से हो रही है, आप जल्दी पास होने वाले हैं. ओके, वेरी नाइस, वेरी गुड. So what happened? You have S trans and S cis. So S cis, what S cis or reactive or trans S is more reactive. In the Diels-Alder reaction, you got that there is one single bond rotation happen in trans S. So what I called as that there is a one single bond rotation. Single bond rotation because there is a one sigma bond and that sigma bond will be rotated. But you know there is, if there is pi bond, you can rotate or not? No sir. If there is a pi bond, we cannot rotate. But if there is a single bond and there is, we can happen or we can do the single bond rotation. After the single bond rotation, what happened? That transdiene become cisdiene. The transdiene becomes cisdiene, and that will be very, very reactive in the Diels-Alder reaction. Okay, you got it? And it is cisdiene is active in nature. Cisdiene is active in nature, and it is trans is single bond rotation happen there. Single bond rotation happen and become cisdiene. Single bond rotation. Single bond rotation, or we call as sigma bond rotation also happen. Single bond rotation is happen and become cisdiene, and cisdiene is active in nature. Okay, for the Diels-Alder reaction we want cisdiene. Okay, so we need to understand first diene and dienophile homo-LUMO approach. Yesterday we understand that homo and LUMO approach of diene, and today we discuss that diene. Okay, today we discuss that dienophile FMO approach. How we understand that dienophile or diene approach, and how many anti-bonding molecular orbitals are there, bonding molecular orbitals are there, which is a homo, which is a LUMO, how we define or how we understand that. Shika successor, very good, you are giving a good answer, very nice. Then we understand, first of all we need to understand that sir, FMO approach of, so if we are doing a reaction of dienophile, this is diene and this is dienophile. If you want to reaction or go doing reaction, so what we do, we want to see that homo-lumo approach. So in the diene and dienophile, what we need to see, dienophile. So in diene and dienophile, we need to see that in the diene, which is the more reactive side, homo will react with dienophile of lumo, or lumo will attack with the dienophile of. Okay, we need to understand that which orbital is interact with the dienophile and which dienophile. Okay, and which is what happen in FMO approach of, this is very important. Okay, so we need to understand most of the case homo of diene interact with lumo of dienophile. Okay, that is very important point. Which point is there? There is most important, most of the cases homo of dienes interacts with lumo of dienophile. You need to understand that diene, what we need to understand, homo of diene, and we got lumo of dienophile. So how we get that homo lumo? So for diene, first case for diene, I will draw all the diagrams of diene. For diene, there is last orbital is very important. Okay, last orbital is very important. Other orbitals are not very important, only last orbital is important. Okay, there is last end orbital is very important for you. Okay, so you need to understand that psi1, psi2, psi3 and psi4. Okay, that is plus minus, sir, plus and plus minus. There is one trick you need to understand. First orbital psi1 is plus, then plus minus, then plus then plus minus. What is this plus minus plus? That is first orbital of psi1, and end orbital of plus is plus. It means this is plus and this is also plus. Upper orbital is plus, upper orbital is plus minus, because they are showing the plus minus, and first orbital of psi3 is plus, and second end orbital also plus, and first orbital also plus, and end orbital is minus. So if they are asking how many bonding orbitals are there in the psi1, question arises that now you clear that you want to very well focus. CSIR will ask you now how many bonding orbitals in the psi1 or psi2. Then how you give an answer that you are giving from one trick. What is the one trick? Sir, n minus 4 minus 1. So 4 minus 1 is 4. Why we take 4? Because how many carbon are there? There are 1 carbon, 2 carbon, 3 carbon and 4 carbon. if there are 4 carbon, 4 minus 1, what we got? What we get? 4 minus 1, we get 3. So 3 are bonding, 3 are bonding orbitals. Okay, after that we get 3, after that we get 2, and for this is for psi 1, this is for bonding, 3 bonding orbital is for psi 1, and after that you reduce the number or decrease the number of bonding orbital. If you reduce the number, psi 2 you get 2 bonding orbital, and psi 3 you got 1 bonding orbital, and psi 4 you got 0 bonding orbital. Now how you get anti-bonding orbital? Sir, reverse the that order. Reverse the order. How you reverse the order, sir? That 3 bonding orbital is here, so there is anti-bonding is 0 anti-bonding. Okay, you got there is 0 anti-bonding, and after that there is 1 anti-bonding, and there is 2 anti-bonding. So you need to understand that there is only anti-bonding molecular orbital. Okay, and there is 3 anti-bonding molecular orbital. Nowadays they are asking you how many anti-bondings and how many bonding orbitals. So you need to understand the concept of bonding orbitals and anti-bonding orbitals. How you got bonding orbitals? You got from their diene. And how many diene are there? Only 1 diene is there. How many carbon atoms are there? 1, 2, 3, 4. And if you are minusing 1 orbital, it means 4 carbon are there. So 4 minus 1. 4 minus 1, you got how many? 3 bonding orbital. If you got 3 bonding orbital for psi 1 case, now you are doing your well work. How you are doing your well work? So if you got psi 1 3 bonding orbital, you can reduce your or decrease your bonding orbitals. So from 3 to 2, 2 to 1, 1 to 0. Okay, after that there you need to know that how many anti-bonding is there. There are 0 anti-bonding in psi 1 case, and psi 2 case there is 1 anti-bonding. Reverse the order, that you need to understand. Reverse the order. 3 bonding orbital, and psi 4 you got 3 anti-bonding. Psi 1 you got 3 bonding and bonding orbitals, and psi 4 you got 3 anti-bonding orbitals. After that you know that psi 1 and psi 2 in the presence of heating condition, you know that there are orbitals. Okay, in the heating condition we know so there is psi 1 case, psi 2 case, psi 3 case, psi 4 case, and there is so many. So how many orbitals? How many orbitals? 1 orbitals. In the presence of heating condition or thermal condition, what happen? How many electrons we put in psi 1, psi 2, or psi 3, or psi 4, or psi 5? So in the presence of H nu condition, photochemical condition, how we put electrons or how we excited that electrons in that system of thermal and photochemical condition. What happened in thermal condition? What happened in photochemical condition? We put how many electrons? Pi electrons are there? There are in diene there are 4 pi electrons. How you got 4 pi electrons, sir? 4 pi electrons from the pi bond of electrons. Pi bond here. How many pi bonds are there? Only 2 pi bonds are there. Why 1 pi bond contains 4 electrons? 4 electrons you want to fill, you need to fill. So 1 or 2, okay. After that you need to fill that 2 electrons in Psi2, and this Psi2 will become that homo of diene, homo of LUMO of Psi3 is a LUMO of Psi3 is the LUMO of Psi3 is Psi2 is a HOMO, and Psi3 is in which condition? Thermal condition or photochemical condition. If presence of HNE condition, what happens, sir? In HNE condition, we fill the electrons in HNE condition, then we got that. So how many electrons we need to fill? 4 electrons. So how you fill? First, second, and third one is here, and after that 4th electron will excited in HNE condition. In photochemical condition, 4th electron is excited from its state. If we are filling here Psi2, but they are excited 1 electron of Psi3 in the photochemical conditions, what happen? 1 electron will break, 1 electron will break. It means like radical reaction. In radical reaction, what happen? 1 electron will break and 1 electron will break. Like homolytically cleavage. If homolytical cleavage, what happen? In you know just Jablonski diagram. In Jablonski diagram, what happen? From directly, if electron is excited, one electron is excited from the, so what happen? 1 electron is go in the Psi3, okay, and Psi3 it is HOMO or LUMO. That is Psi3 in the condition of HNU. Psi3 is HOMO. If in the HNU photochemical condition, you got Psi4 LUMO, Psi4 LUMO condition. Okay, Psi4 is LUMO and Psi3 is HOMO. For that is a diene purpose only. That is a diene. So you got which is HOMO. HOMO highest molecular orbital you got. HOMO is Psi2, sir. Then you need to know that Psi2 is which sign? They are end orbital are which sign? They are positive. End point is positive. Okay, you need to remember that because we want to react the HOMO of diene, because we need to react that HOMO of diene. You need to understand that we want diene of HOMO, and which is HOMO? HOMO we got HOMO of in heating condition we got HOMO of Psi2, which are they sign? They have Psi2, Psi3 and Psi2 no? It's Psi2, sorry, it's Psi2. It's not Psi3. It's not Psi3. It is Psi2. Sorry, it is Psi2. So Psi2 is this. Psi2 is plus or minus. Okay, Psi2 is plus minus. In thermal condition, we got HOMO is Psi2. Okay, in photochemical condition, what we get? In photochemical condition, we got that Psi3 is HOMO. Okay, you need to remember that the Psi3 is sign. Psi3 sign is that Psi3 sign is plus plus. Psi3 sign is plus plus. In photochemical condition, you need to remember that n orbital of plus plus sign. And in HNU thermal condition, heating condition, what we get? This Psi2 is HOMO and end orbital is plus and minus. So you need to remember here that end orbitals of in heating condition in heating condition we got HOMO is Psi2, and end orbital is plus and minus. Okay, plus and minus. In HNU condition you got Psi3, and Psi3 is HOMO, and you got end orbital sign is plus and plus. Okay, so you need to remember that after we are doing the reaction of diene and dienophile, what we get, that is the main important point for you. Okay, that will you get diene, whole diene, you understand, whole diene, which is HOMO and which is LUMO. You only understand that you want to take diene of HOMO only. When you react with dienophile, we want only HOMO of diene. Okay, after that we need dienophile HOMO or LUMO. We want dienophile LUMO because they are saying interaction with LUMO of dienophile. So we need to find that which is the LUMO of dienophile. So next page we need to see that which is LUMO of dienophile. First, which orbital are there? Two orbitals are there. First one is, so here we discussing dienophile. So which are the orbitals? Just like first orbital is plus, and next orbital is plus and minus. They are psi1 and they are psi2, and they are plus in nature and plus minus in nature. So what happens, sir? How many bondings and anti-bondings? Sir, there is only one bonding and there is only one anti-bonding molecular orbital. Okay, so there is bonding molecular orbital, only one bonding molecular orbital, and one is anti-bonding molecular orbital. So in that there is heating condition, what happened? In heating condition, what happened? Heating condition, we need to fill electrons. How many pi bonds are there? How many pi bonds in dienophile? Only pi bond is 1, so only 2 electrons we need to fill it. In the which orbital we need to fill? Very basic or ground state orbital we need to fill the 2 electrons of pi electrons of pi bond. Okay, 2 electrons of pi bond. So we need to fill 2 electrons of pi bond here in the bonding orbital interaction or bonding molecular orbital. We feel that 2 electrons in the orbit, and we get that is psi1 of, in thermal condition we get HOMO of this, and this is LUMO, and this is anti-bonding molecular orbital is psi star. So you need to understand, sir, very important point. What is the very important point, sir? What is the very important? In psi anti-bonding molecular orbital, you are giving star. It means psi1 and psi2. Psi2 is in the star form. Why we are giving star? Because they are in anti-bonding molecular orbital. Okay, so that is the point, is that orbital is anti-bonding molecular orbital is HOMO or LUMO, that is psi2 star. In the heating condition you will get LUMO, lowest unoccupied molecular orbital. LUMO is what does it mean? LUMO is lowest unoccupied molecular orbital. Unoccupied means यहाँ पर कोई भी इलेक्ट्रॉन नहीं रहेगा. There is no electrons in unoccupied molecular orbital. U means unoccupied molecular orbital, or and there is HOMO. HOMO means highest molecular orbital, highest occupied molecular orbital. Occupied means there is some electrons in the orbit. That's why they are called as HOMO. Okay, HOMO means highest occupied molecular orbital. Occupied means the orbital, there is some electrons are filling. That's why they are called as HOMO of that side 1 of dinophile. Okay, clear? So in we see in the presence of thermal condition you get HOMO and LUMO, and for dinophile we want only LUMO. Okay, for the reaction with which dine with the reaction of dine we want only LUMO of thermal condition of dinophile. Okay, in what happen in the H nu condition? What happen in the H nu condition? In H nu condition, what happen? We need to understand in H nu condition what happen. One electron is goes here. Okay, one electron is goes there. So what happens, sir? It's very important condition is there. So we need to understand bonding molecular orbital and anti-bonding molecular orbital. There are two orbitals. Okay, this is psi1 psi2 and this is psi1. Okay, this is psi1 and this is psi2. This is one orbital and this is one orbital. In H nu condition what happens, sir? Now you need to understand one electron of excitation. If you excited one electron and one electron you fill, and now you get two electrons or two electrons here. The ground state, you need to understand first ground state, and after that you need to understand that excited state. In the ground state what happened? Ground state, two electrons are there, so here you write that ground state. After that ground state, one electron is excited. That is HOMO or LUMO? HOMO only. That is HOMO in nature, and that is LUMO in nature. Okay. So after excitation of one electron, after excitation of one electron, H nu is excitation. Excitation of one electron. What happens, sir? Excited one electron. What happened? We get that two orbitals we have. Okay, so they, if we put one electron is excited from here, that is bonding molecular orbital, and one electron is, if we are exciting, sir, so one electron is goes here, and we get that, sir, that is HOMO or LUMO. That is, sir, if they are HOMO, so we get HOMO. They are HOMO. Highest molecular orbital we got in H nu condition, photochemical condition, we got only HOMO. There is LUMO or not? There is LUMO or not? There we get LUMO or not? Please tell me. There we get LUMO or not? We don't get LUMO. We don't get LUMO. So here is one very important point. We don't get LUMO in H nu condition. Sir, sorry for the disturbance. So here we get that LUMO not available. LUMO not available. So we pick LUMO of ground state, that is before the excitation. Here one point is important, sir. What? That is ground state and that is excited state. That is excited state. Excited state. In excited state, sir, we don't get any LUMO. You need to understand that very important point is there. We don't get LUMO. You see, there is only HUMO is there. After that, one orbital, we don't have any orbital and vacant orbital. And if there is no vacant orbital, sir, but sir, before excitation condition, LUMO are present. That's I call as na. See that LUMO of ground state, that is before excitation. Okay, so before the excitation, you get LUMO of this, and we will take that LUMO from the before the excitation of ground state from the. So in H nu condition, before the excitation of electron, we get that ground state condition. The LUMO is Psi2 antibonding molecular orbital. So what happened? You need to understand for H nu condition, you see that before the excitation of before the excitation of electron, you get that LUMO in the Psi2 condition. Okay, so Psi2 condition, there is LUMO not available, so we will pick LUMO of ground state, that is before excitation. Okay, so आपको अभी समझ में आ रहा है? So we get that LUMO in the H nu condition. Okay, that is Psi2 antibonding molecular orbital. So today, so LUMO for H nu condition, you get Psi2. Okay, for H nu condition, photochemical condition, you got LUMO for H nu condition, and for thermal condition, you got Psi2. In presence of thermal condition, you got Psi2, which is LUMO. So when we heated condition, now we will see there is 1000 plus IFAN qualified, CSIR, UGC net, CSIR net qualified. Okay, you can also join and success your journey, and you will join it fast and become a member of successful member. Let's see. I don't have one. Wait. I want one new file. Wait. So we need to understand fast. We need to understand that fast reaction. Okay, only one slide is I will add it. Okay, so that first one slide is added. I heating condition H nu. So brightness is so much na. Sorry. So for today's, it's sufficient for today's, because there is no slides. I will add tomorrow. I will add some slides and I will explain that in the morning first. Next session, tomorrow's session, before going to endo roll, I will explain that heating condition and HNU condition is suprafacial or intrafacial. That is very, very important for you. So you need to understand tomorrow heating condition and HNU condition. There is supraspatial and intraspatial, and suprafacial what it's allowed or not, and intraspatial is allowed or not. You need to very, very important to understand that concept, and very, very important you come tomorrow at the time of 9 a.m. So sharply join at 9 a.m. tomorrow. Okay, so today's lecture it's dyne and dynophile. I will it's over for today's lecture. Tomorrow I will come fast and I will join and explain that first intrafacial, suprafacial is allowed or intrafacial is not allowed. We will take or see the concept of intrafacial, suprafacial is allowed or forbidden. Okay, so for today's lecture is now over, and thank you so much and happy learning. Ashika, Vikram, now you are understanding the concept, or it's easy or not? Please say something. It's you are understanding or not with the basics? You understand or not? Please tell me in the comment section. Those who are watching, please tell me you are understanding or not new concept. Anything else? If you are not understanding anything, you can ask me any question or you can contact me directly. There is no any other issue. Okay. Anshika, if you have any query, you can ask me anytime. Okay. Hello, Pramod. Hello, Pramod. Why they are disturbing camera? What happened, bro? Oh. Hello, Pramod. How are you? How are you doing? You are understanding my concept? Understand my explanation and understanding or not? You got all the concept? Full concept you understand or not? If you have any query, you can ask me. Feel free to ask me anytime. Okay. So thank you so much, and you need to very, very focus because gate exam is nearby, set exam is nearby. So you don't relax it. So you need to very, very focus, and you need to focus all the subject of physical chemistry, inorganic chemistry and organic chemistry, because in gate exam they are asking very conceptual question. If your concept is clear now, then you clearing the gate exam. If you are preparing for gate exam, set exam or net exam, you need to understand all the concepts of questions, how many questions are, which from the which topic are comes, how many questions are come from that topic in the gate exam. You need to very, very focus, or you do your best study or do your hard work, because from the hard work you got a success, a huge success, and you get a best rank. If you get a best rank, then you go in the IITs or NCL, ISIR, Pune. So many ISIRs are there. Okay, so you go in many institute. Okay, so if you want to go in the best institute, in the best guide, so you, if you want best guide and best institute, so you need to do a study very deeply and understand every concept of every question. So if you are doing very well your preparation, so you can crack the exam. So you well study and hard work very patiently, you can doing all the things. Okay, so thank you so much for today's lecture and happy learning. Today, tomorrow you connect on 9 a.m. Okay, bye bye. Have a good day, and with motivatedly you are doing, don't waste your time before the gate exam, because gate exam you have in the next month. So much less time is you have, so that time is very very important or crucial for you. Okay, so if you are wasting your time in for mobile watching, if you are going here and there, going here and there outside, so you are wasting your time. If you are wasting your time, your rank will be decreased. If you are increase at that time, if you put some or see some concept video, or if you are using that time for solving the problems or solving the PYQ questions, then it's very very important for you, because if one of the question or one of the concept is come from that PYQ or any other concept, so you got marks, and from that marks you will increase your rank in the gate exam. So you will very well prepare. Thank you so much and happy learning. We will meet tomorrow. Thank you.